Okay, so we are on the topic logic gates. This is our topic in 9618 AS level computer science, chapter number 3. It is a part of chapter 3 hardware. Okay, so the logic gates are of 6 types, and in its start, we are going to study 3 logic gates. You can see the symbols here, and, or, and not. These are the 3 logical symbols for the logic gates. So we are going to start the AND gate first. We need to remember whenever we performing any logic gate, we need to follow these 3 things. The first one is formula. The second one is truth table. And the third one is logic gate or circuit. You can say it is circuit as well, right? So we need to deal with the 3 steps. Step number 1, we need to apply the formula. Step number 2, truth table. And in step number 3, we need to draw a logic circuit. So I'm going to write logic circuit instead of logic gate. Right. Always we need to follow these 3 steps. So what is the purpose of AND gate? Why we use AND gate? Just hold on, please. Okay. So what is the purpose of AND gate? AND gate performs multiplication. It means that we have a logical expression. Look, A and B is equal to C. This is called logical expression. And in between A and B, you can see there is a dot. This dot represents multiplication. Of course, you know the basic, for addition, subtraction, division, multiplication. And you know the basics of multiplication is we need to apply a dot, or sometimes the numbers are written without dots like this, right? So if you found a dot or the numbers with no signs, so it means the values are multiplying. So in computing, multiplication is known as AND gate. So this is called logical expression. It looks like an equation if you solve algebraic questions. So you can think, sir, it's just like an algebraic expression, but in computer, we called it logical expression. Remember, logical expression. I'm calling this word again and again. It means it is important. Okay. In our logical expression, we have 2 sides. The side before is equal to is called input, and the side after is equal to is called output. The side before is equal to is input, or you can say on the left hand side, we have input, and on the right hand side, we have output. So we come to know that AND gate performs multiplication. We have a question in logical expression, and we must need to declare what is input and output for our own, for our own understanding. In exam, it is not mandatory. You need to just solve the question. That's it. But right here, we are learning it, so we need to understand. Okay, so now I'm going to start the question. As I told you, we have to perform 3 steps. Step number 1, formula. So I'm using the formula 2 power n. What is n here? N means number of inputs. Can you tell me how many inputs we have? See the logical expression?
2.
Yes. So instead of 2, I write 2 power 2. Like instead of writing n, I just write 2 here. If we have 3
Yes.
variables, so we need to write 3. So right now we have only 2 variables. So 2 power 2, 4 combinations. It means once we are going to draw the truth table, we need to make a combination of 4. Like we need to draw the 4 rows. So I'm moving to step number 2, truth table. I'm going to draw a truth table now. So you can see I just draw just hold on. Wait a minute. I'm just going to draw it again for you. I just make it blank so it will be easy. Still you're coughing. Okay, this is a blank truth table. It's blank, right? Now we're going to make a truth table. So as you know, 4 combinations are there. So we are going to draw the 4 combinations. Look, 1, 2, 3, and 4. Now see the logical expression A and B equal to C. This is our logical expression. How many variables we have?
3.
No.
3.
You need to only count input.
Input 2. 2 input.
Okay, tell me the name of the variables. A
and A and B.
And what is the resultant of A and B?
C.
Of course, C. Very good. This is my truth table now. Okay. Now we are going to input the values in the truth table. So this is the output. This is the result. So we are not going to start putting the values from this column. So what is the next column after this? B. Of course, B is an input, right? Look, in input, we have declared A and B. So we need to start inputting the value from this column. And our values will be like this: 0, 1, 0, 1. And then in A, 0, 0, 1, 1. Once you are going to draw a truth table for 2 inputs, the same values will be written in a way like I do. Like in the first column, 0, 1, 0, 1. In the next column, 0, 0, 1, 1. Always. You need to learn it by heart. Once you are going to draw the truth table for the 2 combinations, 2 variables, the first value will be 0, 1, 0, 1. And the second value is 0, 0, 1, 1.
But what if there are 3 inputs?
Yes, if we have 3 inputs. So it means 2 power n will be changed. If we have 3 inputs, so I'm going to write 2 power 3. So tell me what will be the answer, 2 power 3?
2 power 3 is 9.
No, it's
Sorry.
8.
Sorry.
2 power 3
Sorry,
means
8.
2 into 2 into 2. So 2 2s are 4, 4 2s are 8 combinations. So we need to draw a big truth table for 8. And we have 3 variables. Let's suppose the C is a third variable. So we need to write in this way: 4 times 0, 4 times 1. I told you it will be a big truth table, no? So all of the columns are extended, like again 0, 1, 0, 1. Like again 0, 0, 1, 1. Look, whole columns are changed now. Once we have 3 inputs. This is a pattern of the 3 inputs. Like in the first column, we have 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 8 times. 0, 0, 1, 1, 0, 0, 1, 1, 8 times. And 4, 0, 4 ones 8 times. So in this way, you are going to draw the truth table for 3 variables. But right now we don't have 3 variables, although I tell you. But right now we have only 2 variables, that is A and B. So I need to remove it, otherwise you will get confused. Okay, why did the teacher draw this big table? Okay. Now, can you tell me what is the relationship between A and B?
A times B is equal to C.
Okay, what is the relation A and B? Like, what are they performing? AND gate. AND gate performs
Multiplication. So A times B.
Yes. So 0 zeros are
Yeah.
0. 0 ones are 0.
Yeah.
1 zeros are 0.
0.
And finally, 1 ones are 1. So this is our output, right? This is our output. How do we gain this output? We just multiply the values, isn't it?
Yeah.
So AND gate always performs multiplication.
Yes.
Okay. Now, okay. So in the next step, step number 3, we are going to draw the logic circuit. So logic circuit is going to draw with the help of a logical expression. Look, I have written down the logical expression, and now I'm going to draw the logic circuit with the help of logic expression. So you can see we have A and B equal to C. So I just write A and B. And now I'm going to draw the logic circuit. So I'm going to make a line like this, and from B like this, and we have an AND gate. As I told you, the shape of AND gate is just like a D. So look, I have just draw it, and the answer is C. Look, A and B is equal to C. So you need to mention the output as well. So in this way, you are going to draw the logic circuit.
Okay.
So you need to draw it quickly.
Done.
Great. My drawing is not good, you know that. So you're habitual now of this type of thing. Okay, so now we have another gate that's called OR gate. The same thing, formula, truth table, logic circuit. So what is the purpose of OR gate? OR gate is used to perform addition. It means that once you saw OR gate, it means you need to add the values. So the logical expression must be written in this way: X or Y equal to Z. You need to read it like this: X or Y equal to Z. This is called logical expression.
Yes.
Same thing is right here, like X and Y is an input and the Z is an output. So let's count how many inputs we have. We have 2 inputs. Look, X and Y. Then we apply the formula. Formula is equal to 2 power n. Instead of n, again, we are going to write 2. So 2 into 2 becomes 4.
4.
After driving how many combinations we need to draw in the truth table, we are going to start drawing the truth table. In the truth table, we need to make 4 rows for the data. And then we are going to write down the values of columns. This is an empty truth table, let's suppose. It's empty. So now we are going to read the expression again. X or Y equal to Z. So the first variable will be X, second is Y, and the third one is a resultant X or Y equal to Z. So this is the output, as I told you. So what is the input? Which column is input?
The first 2.
The first one is the first input. So from the first input, we are going to feed the values. Tell me the values.
0, 1, 0, 1.
Yes. Next value.
0, 0, 1, 1.
Yes. Great. In this way, you are going to write down the values. Okay. Now the next thing, what you are going to perform in the truth table. Tell me. What we are going to perform in OR gate.
We add all the inputs. So 0 plus 0 is 0, 0 plus 1 is 1,
Very
1 plus 0.
good. So the story is 0, 1, 1, and 1. This is our story. So in this case, we just apply 0. Because, sorry, 1. Because 0 plus 1, 1. 0 plus 0. Hey, we have done some mistake here. Look.
Yes, 1 here. Yes.
Yes. We need to awake all time, you know, because if we are not going to, you know, see the things, we will lose the question. So 0 triple 1 is our answer. We apply addition. Now the logic circuit. The same, we need to draw the logic circuit. First, I'm going to write down the logical expression as it is already written, x or y equal to z. So we are going to draw the lines like this. It's a pretty good design. And the OR gate. Look. So this is called your OR gate. That's it. This is a logic circuit. Now you need to write it down in your notebook. Quick. Is now the next logic gate is NOT gate. Okay, NOT gate is used for invert or opposite the values. Like in this gate, we have only one value, that is A. And the invert of A will be written in this form. Like we need to write down A and we need to make a bar over it. Look, bar. So this means not A, right? Not A. You can read it like not A. So remember, if you have a given value 0, not A will revert the value into 1. And if you have a value of A 1, not A will revert the value in 0. So it opposites the value.
Yes.
And represent not by a bar. And the logic circuit will be drawn like this. Right?
Okay.
So draw it now.
Yes.
So the question is solve the following logical expressions. Remember, logical expressions. So you can see we have a logical expression A or B and A equal to C, right?
Yes.
A or B and A equal to C. This is our question. Okay. Now, first thing, how many variables are there? Can you tell me?
A and B and there are 2 variables, right?
2 variables. No, there are 4 variables.
No, but they're basically 2 variables, I think.
So you are saying that once we are going to repeat, we will not recount?
I think so. I think.
Wow.
I'm sure.
Very good. Very good. So we have 2 variables. You saw it here, na? Tabhi to.
No, I didn't. I didn't see it. I just saw it now.
सामने लिखा हुआ है यार.
I didn't see it. I just saw it now.
Okay. देखो भाई, you are absolutely right, and I'm very happy that you are pretty much confident. No sir, it should be 2. That's good. That's a good confidence. देखो भाई, if we are going to repeat the variables again, they will not recount. So if A is repeating twice and B is repeating twice, so they are being counted as 1. So all in all, we have 2 variables.
Yes.
Again, we are using the formula 2 power n. Again, we are going to implement 2 and making 4 combinations. So after driving the combination numbers, like we come to know that we need to draw the truth table for the 4 lines. Now we are going to make a truth table. For my own convenience, I have write down the logical expression again. So the old method will be used. What is the old method? Like I told you that we have 4 values, right? Sorry, we have
Yes.
only 2 values. So we need to draw it again. So I'm deleting it. Hold on. I'm deleting the whole. So we are going to draw it again. Table. Okay. There we go. Right, scratched. So I need to. Okay. So this is my truth table, right? Now I'm going to input the values. What is the first value you saw in my logical expression?
The first value, it's A.
A. Okay, great. A. Next.
B.
Now listen to me very carefully. Once you're going to solve the questions like this, so we are going to make like this. Like these are called parentheses or brackets.
Bracket.
So the first bracket is for A or B. So we need to make a column A or B. Can you tell me the next bracket?
B and A.
Can you tell me the last?
C.
C. What is the meaning of C here?
A plus B times A.
It means that in C, we are going to combine these 2 circuits or these 2 combinations.
Yes.
Do you understand it? So once we are going to write down the C, it means we need to take this column and we need to take this column. But what is the relation between them? The question arises, what is the relation between them? Are you able to see what is happening between them in the middle?
The third and the fourth rows are multiplied.
Multiplying. It means AND gate. So I'm going to write AND like dot. This is AND gate, right? You said don't say multiply. You need to say AND gate. Okay, so tell me what is the first column we need to input the values from where?
B. So 0, 1, 0, 1.
Wow. So you understand it. Great. Okay. So the first value is 0, 1, 0, 1. I need to design it. Okay. 0, 1. No. 1. Okay. Okay, perfect. 0, 1. The next is 0, 0.
0, 0, 1, 1.
0, 1. Now we are going to perform OR gate. So 0 plus 0.
0.
0 plus 1.
1.
1 plus 0.
1.
1 plus 1.
1.
1. Great. Now we are going to perform AND gate. 0 zeros are 0. 0 ones are 0. 1 zeros are 0. 1 ones are 1. Now what we are going to apply between these two in order to get C? See?
You multiply the third and the
And
0
0 zeros are 0. 0 ones are 0. 0 ones are 0. 1 ones are 1. So in this way, we just find out the result of our truth table. Understand?
Yes.
Now the third thing is a logic circuit. How do we draw the logic circuit? So you can see A or B. So I make A or B here. This is my first section. You can see right here that A or B. What is the problem, man? Okay, done. Look, A or B section is right here. Just like we did in truth table. First, we draw this. And then B and A. I'm going to draw B and A like this. And once we get the answer of both, we are going to connect them with which gate? AND gate. So this is my AND gate. And this is my final answer, isn't it?
Yes.
अच्छा देखो ये ना इनिशियल बेसिस पर है. अब मुझे नहीं पता तुमने ओ लेवल में कंप्यूटर लिया था. आई थिंक सो.
No, I didn't.
You didn't. Okay. अच्छा देखो ये ऐसे भी बनता है. हो सकता है तुम्हारी स्कूल टीचर ने तुम्हें ऐसे सिखाया हो. देखो A और B. ये देखो A और B बना रहा हूं मैं. ये देखो OR गेट बना रहा हूं. ठीक है, ये बना दिया OR गेट. अच्छा तुम्हारा मे बी मोस्टली टीचर्स आर गोइंग टू टीच इन दिस वे. A और B हो गया. अब ये देखो A एंड B कैसे बनाऊंगा. इसके ऊपर से U और B से भी एक बार ले लिया. अब इन दोनों के बीच में क्या बना दिया? AND गेट. तो कुछ टीचर्स यूं भी सिखाते हैं. मे बी तुम्हारे टीचर ने सिखाया हो तो तुम कंफ्यूज हो गई हो कि सर आप अलग करा रहे हैं. ये देखो अब एंड हो गया. अब इन ये दोनों आपस में क्या हो रहे हैं आगे जाके सी में? बताओ.
And
तो ऐसे भी बना सकते हैं आप. ठीक है, मे बी योर टीचर टीच यू इन दिस वे. सो both methods are all right, but this is the method which we use. But right now I'm not going to teach you this method, although I just tell you, maybe you got confused because sir you are going to draw the logic gate in another way. My teacher teach me, so I just clear you that this is a good form of logic gate right now in A levels, but this is a beginning level. So I'm taking you as a beginning level student. So that is the reason I'm going to teach you separately. Right?
okay. Yes.
Okay, you need to take the screenshot of the whole question. And today our lecture is still here, right?
Okay. Right.
Okay. Have you take the screenshot?
I have, yes.
Great. So you need to draw it in your homework, right? And then inshallah, we will continue our lecture on Wednesday.
Yes.
Take care. Goodbye.
Okay.